Alright, so my last video was unsuccessful in communicating the concepts of regular polygons. Today I want to work with a new platform and post things to YouTube. What we're going to do is let's just deal with, I'll make it a hexagon. It doesn't matter as long as it's a regular polygon. Now, if you listen to the audio from my last video, you know what a regular polygon is. However, I'm guessing a lot of people didn't listen since I only left them up for a day or two. So regular polygon means that all the sides are the same and all the angles are the same. Now, regular polygons have what's called an apothem, labeled here with lowercase a. Now, apothem is a lot like the radius of a circle. It goes from the center of the regular polygon to the exterior. Now, what's really cool about regular polygons is that we have a nice formula for their area. Their area is equal to the number of sides they have times the length of one of those sides times the apothem divided by 2. So as you're working through your Get More Math, you were presented with a couple problems, and I'm going to work some examples for those. Let's see. For example, this one that I'm reading, it says, find the apothem in millimeters of a regular heptagon. Heptagon has 7 sides, so I'll go ahead and draw that. Now, if you don't know how many sides a heptagon has, you own Google. Well, you don't own Google. If you owned Google, you wouldn't be my student. But you have access to Google, so you can find out how many sides any shape has. Okay, it says the regular heptagon with a side length of 15 millimeters. So we're going to go ahead and label one side length 15. Now, we could go ahead and label them all 15, but it doesn't matter because we know they're all the same, and we only really need one of them, but I'm just, to drive home the point of regular being all the same sides, I'm going to label those. And it says it has an area of 817.43 millimeters squared. And I guess I should mention that this 15 is also in millimeters, just so all of our units are the same. And we want to find the apothem. So that apothem is that distance from the center of the circle to the edge. Now, we're going to use this formula. How many sides does this have? 1, 2, 3, 4, 5, 6, 7. So we know that n is 7. N is 7, the side is 15, and we're trying to solve for our apothem. So we'll have 817.43 equals n, which is 7, times side, which is 15, times apothem, divided by 2. Now, generally speaking, I would say, okay, plug it into numeric solver, and you're done. Some of you guys don't have access to numeric solver, so I'm going to go ahead and do this the long way for your viewing pleasure. So first, I need to figure out what 17 times 15 divided by 2 is. Sorry, 7 times 15 divided by 2. Okay, so now I know that 817.43 equals 52.5. A. And at this point, we should know we're going to divide by 52.5. This is going to give us an area, which, again, I'm going to use my calculator for because you should at least have a 4-function calculator and be able to do this part. You'll notice that I'm using the TI-30XS calculator. It's about $15 at Walmart. I know times are tough right now, but if you need access to a calculator, it's a pretty decent calculator. And this is saying round to the nearest hundredth, so I have 5600. So those zeros are going to make that 7 stay the same. And that is how you solve for the apothem, given the area and side length. Okay? That's not bad. You probably hear my son, who's joining us as a guest star. Okay, we're given another problem now. We're going to just keep using this formula the whole time, so go ahead and write that down. Okay, that should have given you enough time to write down. Now, you want a piece of paper yourself, Dennis? So you can color?
Yeah.
Okay, I'm going to give my son a piece of paper, and then we're going to get back into this lesson. Okay, so let's say they give you something like this. They say, find the area of the regular octagon to the nearest hundredth. And they tell you that the apothem is 8, and the side length is 7. Okay. How many sides does it have? And we're just going to be filling out this area equals number of sides times the side length times the apothem divided by 2. Well, it's got 1, 2, 3, 4, 5, 6, 7, 8 because it's an octagon, so we have 8 sides. Those sides are 7 long. The apothem is 8 long divided by 2 equals area. Again, you own a calculator or you've downloaded one. I do like the fraction function here. It's a nice little fraction button there, and it just makes an instant fraction, which appeals to me.
Hey, look at me fancy picture.
That's a very fancy picture. Do you want to show my students?
Yeah.
Okay, guys, this is Dennis's picture, so there you go. I'm sure they love it. So once we plug that into the calculator, we find the area of this regular octagon is 224. I didn't ever put units, so I'm just going to say units squared to remind you that units are a square measurement. Okay, now let's think about a different possibility. Let's say I gave you a pentagon.
Hey. Daddy.
And I told you the apothem was 3 long.
Daddy.
And I said, find the area.
Daddy.
And so then we're like, okay, let's use our math brains. Yes, Dennis.
Got old.
No, that one's just white. So when you color on white paper, it doesn't show up. So what I want to do is just use the same formula, right? So I say, okay, there's 5 sides. Simple enough. Oh, and then there's the side length issue. We don't know how long one of these side lengths are. We do know the apothem is 3, and we're going to divide by 2, but we need to find a side length. We'll call our side length S. I don't know what it is. So what we have to do, unfortunately, is use trig. I know you guys missed trig. Now, every single polygon has a bunch of little triangles in it. Right triangles. Now, we can solve for this angle. This is a pentagon, right? Which means that we are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these little triangles. Now, we have 10 of these triangles in a circle, so 360 divided by 10 gives me 36. So this angle right here that I've marked with the little swoop, that's 36. Now, I'm trying to solve for this side right here, which I'll just go ahead and call X for now. I'm not going to call it S because it only covers half the distance. We're eventually going to have to double it. Now I have this angle. This is the hypotenuse over here. I don't know anything about my hypotenuse, so I have opposite over adjacent. Opposite over adjacent. So, ka, toa. That's toa, opposite over adjacent. So the tangent of 36 degrees is equal to opposite, with it, which is x, over adjacent, which is 3. So essentially, I just need to multiply 3 by tangent of 36 because that's how cross multiplication would work. And I have x equals, let's find out. Double check that you're in radian mode. I actually haven't double checked that this calculator has. Okay, I see it's in degree mode right now. Okay, here's mode, radian mode. Excellent. Now it's finished. You want to show them the rest of the picture? Okay, there's the rest of the picture, guys. It's very nice.
It's for both of us.
Oh, it's from both of us? Oh, I bet they love it. Okay, I'm gonna leave mode. Okay, so I'm in radian. Second, quit. Oh, Dennis, I need this. tangent of 36 times, did you finish your hot dog yet? Go finish your hot dog. Times 3. And that's giving me an exceptionally large number. Does that make sense? Oh, I said switch it to radian mode, but I gave this in degrees. So I really need to be in degree mode. Silly Mr. Judd. Sorry, I'm in dad mode, so I use words like silly right now. That's okay. Okay, so let's just go ahead and re-enter that. And it looks like we're getting 2.1796. Always think about your answer. Like, does it make sense if I had gotten that 23? Would that have been practical to have a side length of 3 and then suddenly this is 26 long? Didn't make sense, so I had to reevaluate what I was doing. I'm going to go ahead and just write down a whole mess of these. I don't like to round until the very end. Okay, now, is this my side length? This is where you all say, no, that's half your side length. So what you're going to do is you're going to multiply this by 2 times 2. And that's going to give you a side length of 4.359255. And I'm going to go ahead and plug that in there. Okay? Now, on my calculator, what I'm going to do to do that is I can hit store. I'm going to store that value as x, just to make my life easier. Okay, so that's x now. So now I'll take 5 times x times 3 divided by 2. And it's giving me an area of 32.69 down to the nearest hundredth.
Daddy.
This is what you're going to do if you're given the apothem, but not the side length. Now there's one final kind of problem we need to cover, and then we'll be done with this video.
Daddy?